everyone. It's my first live YouTube session, so I'm pretty excited. I'm pretty nervous too. I don't know why. So I'm just going to do some examples from 13.3, which is evaluating the unit circle. I won't be taking any questions right now. Save those for hours, either tomorrow or Friday. If you could do me a favor though, if you are watching, if you could just like type your name in the chat side of things so I can just kind of get an idea of how many people are here and if it's worthwhile for me to try and do this. Okay, so how to evaluate with the unit circle. All right. You want to find the angle that's being referred to. So for example, if it's negative 5 pi over 4, this is negative 225 degrees. And negative 225 degrees, I would find by going counterclockwise like such. The goal is that you're not going to have to do this every single time. Okay, the goal is that you're going to be able to recognize, oh, that's 45 degrees in the third quadrant or whatever. Now, they don't exist, so it's either 0, 0 degrees, 0 radians, whatever. 30 degrees, 45 degrees, or 60 degrees. That's it. And reference angles are always positive. And then the next thing you want to do is label the triangle. Okay, so Ms. Babiak, this takes so much longer. Why can't I just memorize the unit circle? Okay, you can memorize the unit circle, but you know what I always say, it's much more important that you understand, where it comes from. Okay, so just a little request that if you are here under the chat section, if you could just say hello or type your name or do something so I have an idea of how many people are here watching. Okay, so negative 225 degrees is where I started. Fine, that's what I'm going to stick with. Oh, yay, a couple people are out there. Hi. I'm so excited. I can't wait to see some of you tomorrow in office hours. Oh, there goes Portia. Okay, so she wants to be part of the class too. Portia, going. So let's say I ask you to find the cosecant of negative 225 degrees. Okay, until you get better at using radians and degrees. Sorry, I was going to say until you get better at radians, but it already is in degrees, so we're good. Okay, so 225 negative. Again, you don't have to draw the triangle every single time, but the more you do it, the easier it's going to be, right? It's like practicing, logs. The more you do them, the easier it gets. So 225 degrees, second quadrant. Now I'm going to figure out what the reference angle is. All I care about is the reference angle and the quadrant. So in this case, the reference angle is 45 degrees. Root 2 over 2, negative root 2 over 2. How did I know that? It's from the, I don't know if you saw the video I did where I can strip the special right triangles. So cosecant, reciprocal of the sine. Sine, opposite. So opposite is root 2 over 2. The opposite is root 2 over 2. So the reciprocal of root 2 over 2 is 2 over root 2. Rationalize. And the answer is root 2. So I know I'm kind of doing things out of order. It's been a long time. I don't know what videos you've watched, what you've seen on Khan Academy, what you've seen from your friends, whatever. Special right triangles. Opposite the 30 is 1/2. Opposite the 60 is root 3 over 2. And then, of course, 90 degrees, hypotenuse, always 1. Positive, negative depends on the quadrant. Always opposite the 30 is 1/2, opposite the 60 is √3/2, and then the hypotenuse is 1. And then for a 45, 45, 90, opposite is √2/2, √2/2, and then of course 1. Always. The difference is it might alter a little bit, and that is it positive or is it negative? And that's on the quadrant. So let's do a few more of these. Again, if you have questions, like more specific questions, office hours are tomorrow and Friday. I'm not sure which day is which for you guys. You can come to both of them. I don't care which ones you come to. So I ask you to find the cotangent of, how about 7 pi over 3? The cotangent of 7 pi over 3. So your inkling is going to be to convert it to degrees because you don't like radians, but there are some shortcuts to converting to degrees. To convert to degrees, you multiply by pi over 180. You multiply by 180 over pi. If you want to convert from radians to degrees, you multiply by 180 over pi. Well, watch this. When it's whatever over 3, whatever, 7 pi over 15 pi over 3, negative 29,000 over 3, whatever, when these reduce, you always get 60. So it's a 60-degree reference, always. So if the denominator is some number over 3, it's a 60-degree reference. If it's some number and the denominator is 6, it's a 30-degree reference. And if it's some number over 4, it's a 45-degree reference. So that might be a little shortcut to help you figure out the reference angle without having to do the whole thing in degrees. Okay, so I know that this is a 60-degree reference because the denominator is 3. So the question is it in the first quadrant 60 degrees? Is it in the second quadrant 60 degrees? Is it in the third quadrant 60 degrees? Or is it in the fourth quadrant 60 degrees? Okay, well, I'm not going to lie. I have to think about this for a second. You're probably like, Fabiak, you're probably shouting at the answer to me. I need a minute. It's 420 degrees. 60 was the reference times 7, that's 420. Okay, so it's around. So 420 is going to take me to first quadrant, 60 degrees. Wait, how'd you get that? Around is 360, and then 60 more would give me the 420. I got the 420 because I knew that the denominator was 3, so it was a 60-degree reference, times 7 is 420. This is like half the battle, more than that. Opposite the 60, √3/2. Opposite the 60, √3/2, always. There's no exception to that. Therefore, 30/1/2. Great. Now I can ask you anything. I can ask you to find the sine, the cosine, the cotangent, whatever. I asked you to find the cotangent. Just like in class, I can't get the stupid markers open. Ordered pair, cosine sine, x, y. Tangent is sine over cosine, which is whatever. So those little things, I'll make a cheat sheet, so to speak, for you guys. So if tangent is sine over cosine, then cotangent is cosine over sine. Cotangent is cosine over sine. So this is going to be, help me out here, x over y. The cotangent, cosine x, 1/2. And then sine is opposite. Sine is opposite, which is y, in this case, √3/2. 7 pi over 3. Okay, just remember, if you're just joining us, if you could put your name in the chat, just want to have an idea of you. How about, I want to practice the reciprocal functions. They're harder. You know what? Actually, let's just do all 6 And how about, let's do a negative radian. How about negative 7, 8, 9? Theta, Greek, it's just like X. I don't know why we use theta because there are more letters just to confuse you. All right, reference angle. 30, 60, 45. 30, if you said 30, you are correct. That's my reference. Okay. That's negative. So negative 330. What quadrant is it in? It's kind of weird. Like I'm waiting, hoping that you're like figuring out the answer, even though you're sitting in your bed and I'm like in my garage. All right, anyway, yes, that's where I am. I'm in my garage with this huge whiteboard that I got on Craigslist. I'm going to use theta because I don't want to keep rewriting negative 11 pi over 6. So the sine of theta, opposite 1/2. Therefore, the cosecant is the reciprocal, which is 2. Wow. My handwriting is just as crooked here as it is at school. Should give you some comfort. The cosine. What's the cosine? Root 3 over 2? Secant, cosine are reciprocals. It'd be so much easier if it was sine and it'd be cosine and cosecant, but it's not. The reciprocal of root 3 over 2 is 2 over root 3. Rationalized is opposite over adjacent. 1/2 over root 3 over 2. I feel like we just did this. 1/2 over root 3 over 2. Reduce the 2's, rationalize, and you get root 3 over 3. And then the cotangent. The cotangent is the reciprocal, which is root 3. 6. How about, let's do a 2, 5, 7, 9, 11. I want to do a negative. It's no different than at school. 13 pi over 2. Okay, so it's divided by 2. It has to be either it has to be on an axis. It has to be on an axis because remember when I said that whole thing about you take 180 over 3 and it was a 60 degree, etc. 13 pi over 2 is here. I hope. If that's wrong, then you can tell me later. 0, 1. I think that's where 13 pi over 2 is. 6, yeah. 0, 1. All right, so now the reference angles doesn't help you at all here. You have to know, which I erased, you have to know that cosine is x and sine is y. You have to know that. Oh, by the way, everybody wants to do it reverse. It's alphabetical order. If that helps you remember, it's alphabetical order. There's no reference triangle to be drawn. So cosine, again, I'm just going to go through all 6. Cosine, sine, cosine. Tangent, cosecant, secant, and cotangent. When zeros are involved, you have to be careful about undefined values. Sine is y. The y value is 1. Reciprocal, 1. Okay? Cosine is x. X is 0. The reciprocal of 0, undefined. The reciprocal of 0 is not 0. The reciprocal of 0 is undefined. 0, undefined. And lastly, cotangent is the reciprocal. How do you take the reciprocal of undefined? It's 0. Think about this for a second. Undefined happens when you have some number, any number in the denominator. right? Undefined, any number in the denominator. When you flip that over, you get 0 in the numerator, which is 0. Okay. If you want to type in a question, I can try and answer your question, but this is basically what I wanted to go through. If you have a question, you want to type it in, feel free. Office hours are tomorrow, 10:30 to 11:30. I think. I don't know. I haven't done office hours yet. If you have a question, type it in. Otherwise, I will see you maybe tomorrow. It's kind of awkward standing here in front of my computer. How do I know, by the way, that you're like paying attention? Do you like go idle on the side? Like all I can see are your names and it says hi. But how do I know if you're like still paying attention? You can type that in and let me know. No questions? Or maybe there are and I don't know how to read them. You'll help me. All right, you guys. Well, I hope that. Well, wait. Maybe there's a question. Thanks, Elliot. Elliot says he's paying attention. Thank you. But do you guys go idle? Like, do you know what I mean? Like when you type hi, are you here until you sign off? Or do you go like idle and I see that you're idle? Like, how am I supposed to know what's happening? This is very strange. Well, maybe you say something on my phone. Nothing on my phone, no messages. Okay, everybody's saying. All right, you guys. Well, I guess I'll see you at office hours tomorrow or Friday or not at all. But, hopefully I will see some of you soon. Have a good one.